in option A is given to be 0. So our equation given in the question becomes y double dash plus y equals to sin x. Let us find the CF and PI for this differential equation, and for the CF we take this thing equals to 0, and from here d square plus 1 equals to 0, and here d comes out to be plus minus iota, and so our CF will be a1 cos x plus a2 sin x. Okay, now for the PI we take this one. Here you see d square plus 1, and that will go in the denominator, d square plus 1 and sin x. Okay, so from here we can write this the same thing as you see here, imaginary part of 1 by d square plus 1, and here e to the power ix. So whatever be the imaginary part, that will be our required thing. So here the next imaginary part of ix, and here d plus I square plus 1, here will be x, sorry 1, here will be 1, and thereafter I type here at this place. Okay, so next step will be e to the power ix and 1 by d plus 2id into 1. Okay, now the next step will be e to imaginary part of e to the power ix, and here taking d out common, here will be a square. Let me write clearly. Here will be d square. Okay, d square, and if I take d common, then here will be d plus 2i, and here 1 by d into 1. So the next step will be imaginary part e to the power ix, and here we can write 1 by 2i. The next we can take common, and our d plus 2i, at the place of d plus 2i it will be 1 plus d by 2i to the power minus 1, and this thing you see, this one, this will be x. 1 by d into 1 means integration of 1, so it will be x. Okay, so here will be x, and the next step will be imaginary part of e to the power ix into 1 by 2i, and here will be 1 minus d by 2i, and the higher order we can neglect that, because you know, if you take d2, then differentiation of x will be 1, and again if you differentiate again, then it will be 0. So there is no need to write the higher order of d, higher power of d. So what we have, if you see that here here we have x. Okay, let me write one more step, and here will be 1 by 2i, and here inside the bracket here will be x, and here will be 1 by 2i. So we are getting x. Okay, so it is not bounded. if you can write this the next step will be cos x by 2i. We have to take the imaginary part, so we have to write that as well. So here will be imaginary part of cos x by 2i, and thereafter plus sin x by 2, and here x minus 2i. So our answer will be x cos x by minus 2. We have to take the imaginary part, so x cos x by minus 2, and the next will be minus sin x by 4, and here will be minus 4. Okay, so and you in this you see this is x. If you tend, I show you in blue enclosure. Okay, we have in this we have x, so this will not be a bounded function, it will be unbounded. And same thing you see here, if in other words, if I tend this x to infinity, then cos x is bounded but x is not bounded. Okay, so x will go to infinity. So our first option A is true. Now I go for the next option. And one thing, if you are in the examination hall, then there is no need to go for B, C and D, but here we are for the learning purpose, so we should check B, C and D, why those options are incorrect. Let us check. Okay, so I erase now. Okay, I have erased the whole thing. Now in option B you see a equals to 1, so our equation, differential equation will be y double dash plus y dash plus y equals to sin x. Okay, and from here our to evaluate the CF we take d square plus d plus 1 equals to 0, and here d will be minus 1 plus minus root 3 by 2. Okay, so our CF will be e to the power minus half x, and here inside the bracket it will be c1 cos x plus c2 sin x. This is the CF, and let us now evaluate the PI. So PI will be 1 by d square plus d plus 1 into sin x, and here since the function is sin x, so at the place of d square we can put minus 1. So this will be minus 1 plus d plus 1 sin x, and here will be 1 by d sin x. It means we have to integrate sin x, so this will be cos x. Okay, so complete solution will be y equals to e to the power minus half x into c1 cos x plus c2 sin x and minus cos x. Okay, and now let us see option B. In option B it says that the function the solution is unbounded for this interval 0 to infinity. So if you tend x to infinity, then now let us see the two parts. We see the solution in two parts. The first part is this one. When you tend x to infinity, then this part will be 0. So this part is bounded. And now the second part is minus cos x. Minus cos x is already bounded, so whole thing will be bounded. So this option B is wrong. It is the reason option B is wrong. Okay. And now we in C, for C you see A is same. Here you see A equals to 1, here the same thing. Okay. So we will make this option C correct or incorrect on the basis of this solution you see on the screen. So here it says that x tends to infinity, then solution goes to 0. Here you see x tends to infinity, then solution goes to 0. It is false, because if you tend x to infinity, then this part I show you in red. No, I show you in green. You see this one will be 0 when you tend x to infinity, but when you tend x to infinity, this will not be 0. Okay, this is bounded, but it will not be 0. So our option C is wrong. Now we go for option D, and you see in option D it is A equals to 2. So what should we do? We should solve the equation for A equals to 2. So now I erase this whole thing. Now I take at the place of 2 A, we take 2. So our equation will be y double dash one second. Yes, it is now okay. So for A equals to 2, the equation will be y double dash plus 2y dash plus y equals to sin x. And for this, for the pi, we take d square plus 2d plus 1. Okay. From here d equals to minus 1 minus 1. At the place of d, we can take m. In some books there is taken they take m. Okay, so d and the cf will be c1 plus c2x and e to the power minus x. And here it says that the solution is bounded, but okay. So we find pi will be 1 by d square plus 2d plus 1, and here will be sin x. So we can place at the place of d square minus 1, because here we have sin x. So if you place minus 1 for d square, then this becomes 1 by 2d sin x. And from here the solution will be pi will be half minus half cos x. Okay, so the solution will be c1 c2x e to the power minus x minus half cos x. And you see that if you take x to infinity, here it is minus infinity. If you take x equals to minus infinity, then this will be positive and it will go to infinity. So this whole thing will be a large number. Okay, a large number. So we cannot say it bounded. It says bounded, but it will not be a bounded. This one is bounded, it is okay, but this will not be a bounded function. because e to the power minus x will be positive, a large number, very large number. Okay, so here also you see there is x, and here at the place of this x you have to also place minus infinity. Then you are not getting a finite number, there will be a large number, and so unbounded. But it says, the option D says that it is bounded, so D is also the correct option, incorrect option. So the option to be marked is A.